Hello, in this session we're going to look at foundation design with concrete masonry. My name is Sam Rubenzer. I'm the founder of Force Consulting and the managing director. I'm a licensed engineer in the state of Illinois and a professional engineer in several Midwestern states. I got my engineering degree from the University of Minnesota and an MBA from Marquette University. Here, what we're going to do is we're going to identify some places and areas where it's beneficial to use masonry foundation wall. We're going to illustrate some of the design parameters for foundation walls, including strategies for masonry. Basically, just try to define how to be successful with masonry foundation walls. We're going to explore some cost-effective masonry foundations that can be optimized for efficiency, and then we'll review some masonry foundation wall details and best practices. Really, why use masonry for foundation walls? Well, first and foremost, it's less material. We have some consistency with below grade and above grade construction, so that's certainly a nice little advantage. But really, less material is going to equal much lower cost and a far lower carbon footprint. So if we have a sustainability objective or just trying to be responsible with our use of material, I can't think of a better way than to use a partially grouted masonry foundation. But let's go ahead and get into it a little bit. There are some challenges. There's some perceived negatives versus some real challenges. And I do know that change is difficult. We're really handling an increased amount of masonry units due to the increase of wall thickness. So really kind of when we look at, when we get below grade, especially if we have a cavity wall, if we have multiple layers of construction, when we go from above grade to below grade, I know that we have an increased thickness. We have kind of a lot thicker wall that we have to deal with, and that leads to a lot heavier units. And so really it's means and methods. There's some really great tools that we have today for construction. I'll help kind of illustrate some of the different options that are available to help kind of mitigate or eliminate this challenge. Masonry foundation wall failures can be prevented. Really, there's some really nice guides and details that we can follow to prevent some of these potential failures. I think a lot of times when I bring up masonry foundation walls, oftentimes somebody's going to cite a potential or possible failure that they've seen, and oftentimes it gets to, blamed on the masonry, but really there's almost always multiple other factors which cause the foundation wall to fail. So cracks in walls and breaks in walls are certainly things that we are cautious of. The overall failure for the walls, a lot of times it's going to be leading to an excessive amount of horizontal force on the wall. And in historical masonry foundation walls, there was a point in time where people didn't see the benefit to adding reinforcement to their foundation walls, whether they were concrete or masonry. And what you could see was with masonry, that was really very much of a detrimental choice. Not having reinforcement in a concrete masonry foundation wall is what leads to those horizontal cracks. We have that excessive horizontal force. Maybe it's poor site conditions, poor soil. The soil is not draining the water. Maybe it's retaining the water. Frost is then causing that soil to expand quite a bit and causing some very large horizontal pressures. So I know that these failures and these situations have been real. We've observed them here at Forest, and we know that they are due to some real conditions. But I think there's some very, very simple steps that we can use, that we know of good design practices today, where all of these failures can be avoided, and we can have a very successful masonry foundation. So really what causes foundation wall failure? Under-designed, under-reinforced, overloaded are certainly some of the main problems. Concrete masonry walls alike both need reinforcement when they have excessive loads that are going to be placed on them. Unreinforced walls have relatively low capacity. Unreinforced and ungrouted masonry is maybe especially low just because of the less material that you have with a masonry wall system. So if you have an excessive amount of load that's going to be placed on the material that has less, overall material, masonry versus concrete, then it's just going to have less of a section properties to resist some of the excessive load. So soil puts a lot of pressure on the walls. Common failures, wall failures can come from excessive loading, expansive soils, hydrostatic pressure, not draining. So you have excessive load, frost, again, not draining and excessive load. So all of those are just site conditions that should be able to be resolved by having proper site construction that gets water away from buildings, and any water that is near buildings can freely drain down to drain tile, and we get the water off of the design, off of the structure. So reactive solutions to basement wall failures, certainly you can fix the site conditions that certainly will alleviate any future problems. You add external reinforcement. You can do a total foundation or replacement, or you could have some proactive solutions. So reinforced masonry, reinforced concrete walls are both very, very good steps to having a successful basement wall design. But first and foremost, good site conditions are going to be paramount to making an overall successful foundation design. Here you can see a reinforced basement wall with a lot of good details for how to slope the site, drain the site, waterproof the outside of the foundation wall. All really good steps that we can take to have a successful design. So we really can have success with masonry. We need good design, we need good details, and reliable construction. Some of the old residential codes and maybe even some of the current codes allow for unreinforced masonry basement walls, unreinforced concrete basement walls. I've observed plenty of concrete basement walls that have cracks in them. Certainly it doesn't seem to be a good idea to have soil load, a pressure load that's going to be constantly on a material that's good in compression, not in tension. Have some of these horizontal forces on them that cause tension and compression in a wall. So a little reinforcement goes a long way. I certainly think that just adding a minimal amount of reinforcement to your foundation walls really does solve a lot of problems, and that's certainly something that we're an advocate for here at Force. CMHA, the Concrete Masonry and Hardscapes Association, has some really good papers on concrete masonry basement wall construction. So really kind of following through each of these step by step, using 8-inch units or larger, depending on what the actual wall construction is above grade. Using type S mortar is going to be really important. Using some vertical reinforcement bars, trying to space them out to what would be appropriate for design, making sure that if you have any discontinuities in your design that you actually address that and provide reinforcement maybe at windows and window wells, and making sure that we get reinforcement even above the windows. So maybe a bond beam above the windows. We have proper dowels and anchor bolts from the wall to the foundation. Again, making sure that the slab on grade actually gets poured in the right spot and actually can support the base of the masonry foundation wall as well. Making sure that we have waterproofing on the outside. A lot of people have concerns with the porosity of masonry. It does allow water through, but certainly with waterproofing on the outside, then it's not going to let any water even get to the masonry, so we don't have to worry about the porosity, say, of masonry. Making sure that you have a good draining site, and any soil that's next to the wall is free draining soil that can get the water down to a drain tile and away from the building. So there's some really successful masonry foundation walls and these steps that are in this CMHA Tech Guide 3-11 are certainly a good guide for that type of construction. There's a lot of notes that are really not so much about masonry, but about proper site conditions. And again, there's a lot of details that are with CMHA and other online resources that really do point to that very, very important fact of getting proper site conditions for basements. And certainly that's going to be even more important with masonry foundation walls. So again, we have other documents. Tech Guide 5-38 has some masonry foundation wall details. You can see a lot of those different details for different types of construction, how we're framing into different elements, where we want to have the slab on grade relative to the masonry walls, so on and so forth. They're all going to be very important steps to having a successful masonry foundation wall design. There's actually a separate guide altogether for preventing water penetration in below grade concrete masonry walls. So again, making sure that we have water away and good water protection. So there's several different guides. Are certainly going to be great places to start to have proper detailing for these designs. But then going beyond some of those different guides, the code doesn't require foundations to be grouted solid. We know that there's important steps to make it successful. One of the things that does not make it successful is just simply grouting it solid. Getting the water away and the site sloping away from the wall, waterproofing, reinforcement, and dowels are all important. But solid grouting the wall doesn't provide any protection from the overall design. There's other steps that we pointed to are going to be really important. So we really don't need to be grouting these masonry walls below grade. We want to have, say, waterproofing on the outside. We want to have a top course that's going to be a solid grouted bond beam, and oftentimes it's going to be a good practice just because we're transitioning to a different type of wall system above, so it gives us a nice flat surface with the opportunity to kind of transition and provide other dowels from that system above into a reinforced bond beam at the top of our foundation wall. So reinforce it, partially grout it are really good steps for keeping it economical. We talk often about masonry systems, just kind of a general overview. So there's a lot of different places where we use structural masonry, shaft walls and firewalls, shear walls, bearing walls, partition walls, but foundation walls are certainly an important part of the overall successful project, and certainly can be done with masonry. So again, basement stem walls can be lower level shaft walls and shear walls and bearing walls, whatever we're using the masonry for above grades, and certainly transition down to the lower level. Usually when we get to the basement walls, though, we have a lot of them, and so any shear load that we're putting into these walls is going to get distributed along an entire length of wall. And certainly we're going to have more than enough capacity. So it's usually not, when you get down to foundation walls, even basement walls, coming down to a lot of load demand. It usually has to do with just having compatibility with the elements above. It's really going to drive the overall thickness of masonry foundation walls and basement walls. There's other types of site walls that you can consider with masonry as well. For all the same reasons that we can do of the stem walls and basement walls, we can also use masonry for sign foundations, retaining walls. There's a lot of really good places where we can use masonry in our designs. Again, masonry fits into different building systems. Again, for the different types of framing systems that you can have with wood and cold form, steel, concrete, precast, all different types of systems that you can have that masonry foundation walls can fit into relatively well. I would say the exceptions would be if you have a poured concrete building, you could probably do a poured concrete foundation walls as well. So we're going to leave that off. But again, masonry does work in a variety of different ways with different building systems throughout the above grade and below grade construction. So again, for those basement walls or foundation stem walls or retaining walls or site walls, there's all different things that we have to consider for the overall design. First, let's maybe look at also some cost studies. If we look at some cost studies for the overall designs, this goes back to 1987. This is a senior living building, CMU Foundation. This is coming from a design build firm who did the project back in the 80s and used CMU Foundations for cost reasons. We see the most masonry foundations in the design build sector where the contractor is influenced and the team is trying to save money. And so that was a quote from Mr. Pat Conway. So again, we've been seeing masonry foundations used historically in buildings. For some reason, we got away from them. Maybe there was a couple projects where there wasn't proper conditions set up for success for a masonry foundation wall, and so we had maybe some potential problems, and for some reason we got away from them, thinking that all masonry foundation walls and basement walls were going to be problematic. But we know that that's not true, and we know that we can design them and build them very successfully. So for the foundation wall, like I said before, really it's not going to generally be an overall load demand. especially for a stem wall where you're really going to be defining the thickness of the wall based on having some compatibility with what's going on above it. Whatever cavity wall or whatever systems you're having coming down to this foundation wall. So really, it's going to be very easy to have a simple design and simply reinforced and minimal amounts of reinforcement and grout. So it's very easy to see how cost-wise how we can save quite a bit on cost. So here is a project that we looked at. We looked at the cost for this building, and a lot of this, the solutions for this and the cost savings for this came down to switching it over to load-bearing masonry, including masonry foundation walls for the design. So it became a new prototype. It was a large savings. Having the load-bearing concrete masonry building was certainly very important in design, and that also had a foundation that was a one-day masonry foundation. Now, again, it wasn't an overly huge structure, but it was a structure that, again, we didn't have to set forms and set reinforcement and pour concrete and wait a couple days and strip forms. We just set the block, reinforced and grouted, and we were done with it all, the entire foundation for the building in one day. So it was a very simple step, and we certainly saved a lot of time and money on the project. Another foundation wall case study looking at cast in place design and kind of what the typical time frame would be for the construction and the cost would be for the construction. So we looked at a masonry alternative. Again, you could see quite a bit of time savings for this much larger project. It was an assisted living facility in Wisconsin. So you could see that we had quite a bit of a savings, about 35% savings on the foundation costs. So kind of consistent with what they were seeing back in the 80s. We still have those opportunities today. We had cold weather construction, so you could see that there was a little bit of cost for tenting and some of the cold weather methods that we had for setting masonry during some little bit colder weeks within Wisconsin. But again, we still saved over 30% of the project, and we know that was going to be a very effective design. More cost studies. If we look at a stem wall and a different type of project, we look at, again, 16 inches wide. So we have a little bit thicker foundation wall that we're looking at, 540 feet long. We can see what cast in place concrete is going to be, typical reinforcement that you would have there. For, again, this little stem wall, we had 2% cost savings by going to a fully grouted masonry wall. But again, there's no reason to do that. Let's go ahead and go to the partially grouted masonry. If we need to have it waterproof, we can waterproof it. But then we have a 24% savings on cost and a 50% savings on time. So again, we're saving a lot of these setting forms, stripping forms, all of that we just don't need to do with masonry. We set the block, we pour the grout, and we move on. So if we go to the taller walls, again, 16-inch thick walls, 12 feet high, 540 feet long. Again, cast in place concrete. We have certain reinforcement that we have, minimal reinforcement that we need. Fully grouted masonry. Here for a basement wall, we found that these contractors actually already gave us a 20% savings just going to fully grouted masonry. So maybe it had to do with the taller walls and setting forms for those taller walls. It was just going to be a lot less expensive to not have to set the forms and to just place the masonry units and then reinforce and grout them. So we had less time and less cost, even with the fully grouted. But again, there's no reason to do that. We can go all the way to the partially grouted and reinforced, 50% less time. You can see that there's less of a differential there. Really, when we get into a basement walls, maybe we ran into the design being, at 16 inches on center. So at 16 inches on center really means that we're basically half the grout, but we still have a lot of grout in a basement wall. So even though we're saving quite a bit on grout, it's not going to be quite the overall savings that we saw for just the stem wall. So again, the masonry that we're using, it's certainly a lot less material. And I think if anybody, again, is really serious about sustainability and lowering the carbon footprint, and they haven't done masonry foundation walls, I really don't think that they're that serious, because it's a very obvious and easy way to get some very good savings for your design. So we can really lower our carbon footprint pretty quickly just simply by switching to concrete masonry instead of a concrete basement wall. So here we can just, again, do some comparisons. And again, this is just pointing out some of the obvious savings in material. Looking at going from concrete to masonry, just even solid grouted masonry, we have a little bit thinner wall, so we save a little bit of percentage right away. But as soon as we start to partially grout, you can see the percentage of material really increasing rapidly, all the way down to the, say bars at 120 inches on center, where we'd save about 50% of the material for the masonry solution versus the concrete solution. So it's just a really straightforward kind of quick comparison here. And I can do that, just kind of condense that chart down to, say, bars at 48 inches on center and all the other places in between. So many of the masonry basement walls that we've looked at do have some reinforcement in there, usually at 16 or 24 inches on center. Sometimes it could be a shorter wall and some friendly soil that gives us the opportunity to space the bars out a little bit farther. But certainly, whether it's 29% to 45% savings on material, that's certainly a very simple and easy step to save a lot more material for the purpose of sustainability. Also, there's some really good studies that are being done by the NCMA, CMHA group, looking at the different types of masonry, kind of dry cast masonry versus wet cast masonry, really kind of that choice of construction materials being driven by the increasing real versus perceived carbon footprint. So really looking at some of the data, we can see that the carbon sequestration that we have with dry cast concrete is going to be much more favorable than it is for wet cast concrete. So measuring carbon sequestration of concrete really isn't new, but kind of focusing on dry cast now instead of just the wet cast concrete that you have with like cast in place concrete. So we have a lot more data that we can look at from CMHA, and a lot of that's going to be kind of making the argument even more compelling. But again, we didn't really need to go that far to see that we have already had a lot of savings just due to the less material that you needed with concrete masonry versus a poured concrete wall. I also like to point out kind of the foundation difference that we have, and certainly we've heard this argument from time to time where people wanted to use not use masonry within a building, masonry foundations, because they really wanted to go with a lightweight building. And so really when I kind of look at this, and I kind of created a foundation calculator to show that really the load-bearing say masonry design with a masonry foundation is actually going to be a lot less foundation material than the counterpart lightweight walls with columns and piers and footings, and a minimal, you always have to have a minimum foundation even between those column, piers, and foundations. So kind of always looking at the columns and piers as having more material. Anytime that you can get into a continuous footing for load-bearing walls, you're always going to be saving material for any low to mid-rise buildings. So again, just to prove this out a little bit, we did create a little calculator here at Force, and we kind of did some really quick comparisons on the overall just volumes of concrete that you'd save in just the foundation material. So again, the load-bearing wall is going to be quite a bit more economical for a one-story building. Same story for 2 stories, and 3, and 4 stories. So again, we're always having the total volume of concrete be more economical for 1, 2, 3, 4-story buildings. One of the things that I think is really interesting when we study construction, we study the overall types of projects that are built across the United States. Did everyone know that almost 95% of construction in the United States, so again, we're a country that does like to go vertical whenever we can go vertical, but 95% of construction is 4 stories or less. So really 95% of buildings would make sense to use a load-bearing wall solution and not use the beam and post solution where you'd end up with piers and footing pads. So again, just some really quick studies show this pretty quickly. Again, we're making some assumptions to the overall soil bearing capacity and the overall weight of the systems. But again, it's not until we get to a 6-story building. So once we get to the taller buildings, certainly deep foundations, maybe there's some other reasons, but there's plenty of times where we have lightweight walls that actually increase the amount of foundations and foundation material that's needed to support those systems. So it's always something that's a good exercise to kind of prove out, some of these myths that are out there in terms of what's going to give you a lot less material for your design. So again, from a sustainability perspective, lightweight walls actually cause more foundation material, more material to be needed for your design. So load bearing walls, and that makes sense too because you're utilizing your walls kind of multi-purpose for kind of creating the envelope for your building, but then also for load bearing and shear wall designs, because in this comparison, I'm also not doing anything for lateral stiffness and designs. And so adding in those additional forces and increase in forces of quite the magnitude in isolated locations certainly do drive up foundation costs as well. So again, which system requires less foundation material? Again, for all of the buildings up to 4 stories, which again, 95% of the buildings in the country are 4 stories and less, we're going to have simple load-bearing systems coming down to load-bearing foundations that cause a lot less, use a lot less material. So again, we put everything together here in a paper, and you can certainly download that at masonrystructure.com. So the other things that we want to look at if we're doing a complete system comparison, if we're looking at some of these foundations that we need with the load-bearing designs, again, comparing the different systems and frames that you would have with the light walls. Again, we have masonry foundation walls that are load-bearing, that are more than just a load-bearing walls. They're also able to be shear walls, and so certainly the foundation material for that is going to be much more straightforward as well. So again, making sure that we do complete system comparisons, but again, we're getting a little bit off track here, so let's get back to some details for masonry foundations. Some tips for the overall doweling that you have to do for masonry foundations. The code does allow you to move and bend the bar a little bit. So oftentimes when you go from concrete construction, there's going to be pouring those strip footings pretty quickly and placing dowels, again, hopefully before the pour, but as they place the dowels, whether they can exactly get to this precise location to where the vertical reinforcement would be continuing, that it's supposed to be lapped with and doweled with. The code does give some latitude to bending the bar 1 inch laterally to 6 inches vertically. So you can kind of see that graphically here for this design. Next, again, for when we have masonry foundation walls with the single width kind of wall construction above, again, you can see the continuity that you have with reinforcement that's really able to be staying in the same plane with the stem wall below or basement wall below to the single width wall above. You're able to also take the vertical reinforcement, keep it in the same location, but then the grout, again, don't need to have a solid grouted masonry foundation wall. We can partially grout that wall. You can see the top of wall bond beam still in this situation. So again, you have the ability to get to grade, kind of stop construction, have a dowel that's going to be exposed in that design. So again, having the bond beam there, that gives you the ability to kind of transition at that point. But again, having the good site conditions, the soil sloping away from the site and drain tile and all of that is going to be important for the design. So again, a few more tips on that. Again, we do recommend the bond beam block being used, not lintel block. So again, just the type of block that we use at the top of the foundation wall, the lintel block being kind of that U block, is going to be something that's going to cause a little more problems than we want with some of the construction. So again, a bond beam block, giving the contractor a little bit of latitude there is important. Recommending the wall continuity, fixed condition. Again, when we do have the dowels that are coming into play, and we have dowels between the wall above and the stem wall or basement wall below, make that continuity fixed. Have the base of that wall be fixed, and then actually consider that in the overall wall design that you have above your foundation. So again, having that continuity there in detailed is important, but then actually carrying it through the analysis and design, and making the wall above a little bit more economical with a fixed base is a good idea. Anytime that we have again, transition from thicknesses for the different types of maybe cavity walls that you have above, here you can see a very minimal gap being utilized. But anytime you have that transition, utilizing that bond beam at that transitional area to make sure that you can have good support for the masonry wall that's going above. So again, even when we had the single width wall, we recommended bond beam. Here, again, we recommend that bond beam, and it's even more important when we have that transition to a different wall thickness, wall weights that are going to be above. And certainly as that wall cavity gets larger, that's when we do get to the point of maybe using 12s or 16s for the stem walls or basement walls. Again, being very careful with the dowels and reinforcement location. Maybe the reinforcement needs to be offset in the stem wall or basement wall below, so that it can be centered in the wall above is going to be a really important kind of step to make sure that you have, if you want to have a fully fixed base, that you go ahead and utilize that for your design. Here you can also see two different bond beams being used. Again, the lower one going to be important to make sure that we have that transition for the wall. If you do have the cavity wall elements kind of coming down below grade, to make sure that you have that transition there. But then even the carrying either the bond beam or at least solid grouted course above, so that you can have those dowels all the way up to at grade. So at the slab on grade condition is going to be important. Another option, instead of going with the very thick, say 16-inch walls, we could also look at doing a kind of a multi-width construction, even below grade, and maybe that gives us an opportunity to carry the foundation, the insulation down through the foundation. So that can be a very nice option that could be considered to improve the overall energy efficiency of your building by having that nice continuous insulation layer. So again, we have different details. We have some 2D and 3D details to kind of illustrate some of these different points, looking at how these walls can transition, whether we have a single width wall or different cavity walls and cavity wall construction, kind of what that reinforcement looks like and how it gets placed relative to the overall design conditions. Making sure that we lay out the reinforcement, we go again below grade to above grade, carrying with many of the same details and information that you would need for the masonry construction, both below grade and above grade. Other detailing tips, looking at what the code allows, again, depending on who's pouring the concrete. Concrete is not necessarily a really precise construction method, especially when we're a few feet below grade. So recognizing that you can vary the first mortar bed, you can vary the thickness on that mortar bed to make the actual masonry able to be set level is going to be a really important kind of allowance for construction. So if you're going to be out at the site and you're going to be kind of verifying, what different types of joint thicknesses are going to be, typically we want to stick to that 3/8 inch mortar joint that for all of our construction, but recognize that at foundations we do have a little bit more allowance for thicker mortar joints. So again, we've made mention to the cavity walls. Those foundation walls can get relatively quick, fairly quick. So recognizing that we do have tools. This is a image of a mule that is now used for construction, and a mule can be used for a variety of different purposes. With construction, sometimes it's going to be larger units, 12-inch units that can be up to maybe 32 inches long, or 16-inch units. Mule is just going to be kind of a lifting assist where you can build with thicker walls or heavier elements relatively easily. Here you can see a series of mules being set up on a project where, again, we're building these walls, and we can use, again, longer units. We can use thicker blocks, but we can set those blocks pretty quickly by having a few different mules able to be used for design. So again, I do recognize that 16-inch blocks are relatively large and heavy, but again, with the right construction means and methods, we can easily set some of these units. It also does kind of make me pause a little bit. There have been people through the years, as I've been working with the different coalitions for masonry, that different design firms that we've went into that actually didn't know that they still made 16-inch masonry blocks. So they still make them. They're still readily available, and we can certainly utilize those in below-grade construction, where, again, utilizing some of these thicker elements can make the compatibility with the wall systems above work out. Retaining wall, site wall foundations are all different places where, again, we can use masonry for all the same purposes. Really minimal reinforcement, a lot less concrete, a lot less materials, lower cost, lower our carbon footprint. We're not going to spend a lot of time looking at this, and just recognizing that there's plenty of tools available to be able to design some of the different types of elements. Now, certainly you can do the segmental walls that don't require any mortar, grout, or reinforcement, and so certainly those site walls can be built that way with masonry elements, but you can also go with a reinforced concrete masonry solution, and it, again, provides a lot of the same benefits. Another comment or concern that people have had is, again, if you have a building, maybe it is going to be a taller building that has say a post and frame kind of construction or post and beam construction. Looking at when we get below grade, I think it's always important to recognize that you do have masonry piers that are available. They actually have blocks that are made, special blocks for pilasters, but certainly you could just use standard, say, 8-inch blocks to make masonry pilasters. And it's really good to recognize some of the different capacities that you can utilize with masonry pilasters. I think it's a misconception to think that masonry foundation walls are going to have less capacity. I mean, a masonry column might have slightly less capacity than a concrete column, and that's just due to the fact that it's going to be a lower compressive material. But if we look at a masonry pilaster where we can actually utilize the flanges of those walls, those foundation walls, we can actually have more capacity generally with a masonry pilaster than you can have with a concrete column. So here, just kind of showing some different, like a 16 by 16 concrete column is going to have 523 kips of capacity. If you went with a 16 by 16 pilaster with, again, 8-inch flanges each direction, we actually have an increased capacity of 30% to 677 kips. And kind of the same strategy looked at for a 24 by 24 inch concrete column. You have a 24 by 24 inch masonry pilaster that, again, has more capacity because of the flanges that you can utilize for the design. So just recognizing switching materials at that point really doesn't make sense. Keeping with masonry construction and a kind of a continuous masonry foundation would make a lot more sense, even under those high point loads that are coming down from a structure above. So some software tools that you have, certainly we have a lot of software tools that are available for foundation design as well. So we have a nice little review here that we can look at some of the different software tools. And again, we're not going to have a really depth analysis, but anytime that you can use finite element analysis, whether it's above grade or below grade, we do believe that that's going to give us a much better representation of what the forces are going to be on these elements. So if I did a really quick comparison between the different softwares that are available for foundation walls and maybe retaining walls, we have some different software tools that really do directly address the masonry foundation walls. So TEDS is going to be a nice tool that has both foundation walls and retaining walls. We have some tools from IES, a quick masonry or a quick R wall that are going to design some different masonry wall elements for us. We have Elemasonry from NCMA. We also have EnterCalc that can do some of these designs. And again, if we went with the finite element analysis tools, we have RAM elements and RESA 3D that can do some foundation and retaining wall design. Now, certainly you can put some of those same designs within Tekla Structural Designer and TEDS. So we can kind of go through that kind of in a little bit of a indirect route, but we can still get some of those designs there as well, even if they don't have those directly. And again, about doweling to the foundation, if we do, and I mentioned that before, having that continuity with the foundation wall to the wall above, it does make a difference with the overall design load. So again, if we have that fixed foundation, and this is really kind of similar to if you had a steel beam that you have cantilevered, you don't design the backspan of the cantilever as if it's simply supported. And that's really kind of the same analogy that I'm looking at here. If you do have fixity at the foundation, you can really bring down your design moment maybe by 20 or 30%. And that's a good savings for the demand at a wall. If we have that fixity, then we can utilize that to make the overall design a lot more efficient. So that's something that we should utilize, and certainly using some of the different software tools, the finite element analysis tools, would allow us to take some of these steps to make a more efficient design. There's a couple different architectural notes that I want to kind of point out before we wrap up. Some of the different insulation steps that you'd want to take. Again, kind of looking at the creative masonry foundation, looking at continuing that rigid insulation below grade is a really nice step. Again, if we have a masonry wall and a masonry foundation wall that can be continuous, taking it, making it somewhat of a cavity wall with an increased layer of foundation, rigid insulation can be a very nice step for our design. Looking at this, you can also look at what would be considered an overlap strategy. So again, taking the insulation down to getting it below grade, and then having what would be like a 6-inch starter course utilized for some of the veneers that we're going to be designing for, and then lapping our insulation to make sure that we have good coverage for the foundation wall below. And so here you can see an actual image with that starter course, the flashing, and the wall above. Again, looking at different types of foundation systems, looking at a 6-inch masonry. If we only need 12 inches, maybe 12s and 4s can make a very economical foundation wall design instead of getting 16s. And again, maybe that 12-inch course is going to be able to come up to the slab on grade, and then continue above with a different wall system. So we can combine Weiss. We can put a collar joint and some joint reinforcement that would cover these two different Weiss below grade. But again, using the 16-inch masonry and having, say, 8-inch masonry with kind of the standard cavity wall construction above is going to be a very good and economical way to do the design. And it also saves a lot of time in the overall construction process, as you can see from some of the cost and time comparison slides that we had in here before. So a little bit about 16-inch block. Again, they are available. You can see kind of the full kind of gamut of different types of blocks that you can utilize. You have the standard stretcher blocks, you have bond beam blocks, kind of that double U lintel blocks that you can use, and then also pure blocks that you can look at for 16 inches. So again, that good continuity, the reinforcement that you can lap with the similar systems above is also going to be a really good and positive attribute of having masonry foundations with masonry walls above. So a few more pictures. So again, less material, consistency above and below grade, lowering that carbon footprint, lowering the cost, just using some good masonry foundation details and best practices. And so then you can really see that masonry foundations can be optimized for efficiency, but then also be a very safe and reliable foundation wall for your building. So with that, we're going to wrap up. If anybody does have any questions, you can feel free to email me at sam@forceconsulting.com. Thank you.